There are moments in advanced mobility design when a vehicle stops behaving like transportation and instead begins operating as architecture in motion. What stands before me here is not merely a motorhome concept, but a deliberate rethinking of proportion, surface continuity, and spatial authority within the long-range luxury mobility segment. Before we proceed any further, I want to be clear in a composed and responsible way that this is an AI-generated conceptual study, a speculative design exploration created purely for imaginative and analytical purposes. It does not exist physically, it is not a production vehicle, and it is not associated with any manufacturer. What we are examining is a thought experiment in ultra-luxury mobility architecture. Now, with that understood, let's begin the walk-around. The first observation is sheer length discipline. I estimate this concept stretches approximately 14 to 16 meters in overall length, with a height approaching 3.9 to 4.2 meters at its highest roof arc. Yet, despite these dimensions, the vehicle does not feel bulky. It feels elongated, tapered, and aerodynamically intentional. The stance is remarkably low for a vehicle of this class. Ground clearance appears minimal, likely in the range of 140 to 160 millimeters in highway configuration. This suggests an active air suspension philosophy, one that prioritizes on-road composure and aerodynamic efficiency rather than off-grid ruggedness. The multi-axle configuration is particularly noteworthy. We are looking at a tri-axle rear setup paired with a single steer axle at the front, effectively a quad-axle platform. This dramatically redistributes mass across a longer wheelbase footprint. From a structural engineering standpoint, this solves one of the greatest challenges in luxury motorhomes: torsional rigidity across extended spans. With 3 rear axles, load concentration from interior furnishings, water tanks, battery packs, and glazing weight can be distributed evenly, reducing frame twist and improving high-speed stability. In real-world engineering terms, this would also improve braking efficiency and reduce per-axle stress loads. The exterior language leans unmistakably toward aerospace and high-speed rail influences, rather than traditional RV geometry. The front fascia is not vertical, it is swept, layered, and sculpted. Notice the forward overhang. It flows downward into an integrated aerodynamic chin splitter, which likely manages airflow under the chassis. The curvature continuity from the nose to the roofline is uninterrupted. No harsh transitions, no abrupt angles. This indicates a surface modeled digitally with curvature mapping discipline, ensuring laminar airflow across the upper structure. The roofline tapers gradually toward the rear, suggesting drag reduction intent. Unlike conventional motorhomes that function as rolling walls, this concept appears designed with a drag coefficient target that would likely fall dramatically below segment norms, perhaps even approaching coach-level efficiency benchmarks. Surface tension modeling is tight and cohesive. The shoulder line running from the front lighting cluster all the way through the mid-body glazing acts as a visual stabilizer. It compresses vertical mass and elongates horizontal perception. Panel transitions appear nearly seamless. In a real-world execution, achieving this level of continuity would require advanced composite body panels, possibly carbon-reinforced polymer sections combined with aluminum subframes. Traditional stamped steel would struggle to maintain these radii without visible joints. One of the most ambitious elements here is the glazing strategy. The upper deck features expansive, nearly continuous glass wrapping from front cockpit to mid-body lounge area. This introduces substantial structural challenges. Large glass spans compromise torsional stiffness unless compensated by hidden reinforcement beams or a rigid exoskeletal frame. In a future forward execution, we would likely see laminated structural glass panels integrated into a monocoque system. The tint density appears moderately dark, suggesting electrochromic glass capability. From an insulation standpoint, triple-layer acoustic laminated glass would be necessary to maintain climate efficiency and road noise isolation. Given the surface area, thermal management would be critical. In real-world conditions, such glazing would require advanced UV filtration and infrared rejection coatings to prevent greenhouse heating. The exterior finish presents as a metallic liquid silver, but not a standard automotive metallic. The reflectivity suggests a multi-layer ceramic-infused coating system. Light diffuses evenly across convex surfaces, indicating high-quality clear coat depth. This finish is not merely aesthetic. Silver and lighter metallic tones reduce thermal absorption in direct sunlight, lowering climate system load. From a material science perspective, the body likely combines composite panels over a reinforced aluminum chassis, perhaps even a modular aerospace-grade space frame. The lighting signature is disciplined and architectural. The DRLs are slim, blade-like, and horizontally layered. They create a width-enhancing visual effect. The main beam clusters are deeply recessed, likely using matrix LED or micro LED projection systems in a real-world scenario. This would allow adaptive beam shaping for highway travel. The rear lighting, though partially obscured from this angle, appears to follow a horizontal continuity philosophy, reinforcing visual stability. Night presence would be authoritative rather than theatrical. The polished multi-spoke wheels are aerodynamic yet ornamental. Their smooth surface areas reduce turbulence while maintaining luxury visual presence. The tire sidewalls appear moderately low profile, reinforcing the highway-oriented nature of the concept. This is not terrain-biased. This is continental touring architecture. With 3 rear axles, suspension would likely be electronically controlled air suspension with active leveling. Load compensation would adjust in real time depending on occupancy and water tank levels. The roofline is smooth and uninterrupted, suggesting concealed solar integration. Given the surface area, integrated PV panels could contribute auxiliary charging. Satellite communication modules and autonomous sensor clusters would need to be subtly embedded. The clean roof suggests hidden LiDAR housings beneath tinted panels. Structurally, the roof arc likely acts as a primary load-bearing spine, distributing weight evenly along the length. The front fascia avoids a traditional grille. This implies electrified propulsion assumptions. Cooling in such a platform would likely occur through underbody ducting rather than frontal air intake. The lower aero channels appear functional, guiding air along the sides to reduce wheel turbulence. At the rear, tapering reduces wake turbulence. This is high-speed train logic applied to road mobility. This concept does not compete with traditional RVs. It redefines the segment entirely. It leans toward marine superyacht architecture combined with aerospace surface discipline. It is not recreational in tone. It is executive mobility architecture. The intended user archetype is not a casual traveler. It is someone who views mobility as an extension of identity and operational capability. From a maturity standpoint, the design language feels advanced but plausible with future composite manufacturing evolution. My first professional impression is this. This is a concept that respects engineering constraints while deliberately stretching them. It is restrained, controlled, and calculated in its ambition. Even without direct interior visibility, the exterior proportions allow us to logically reconstruct the spatial architecture. Given the height and glazing strategy, this is almost certainly a dual-deck configuration. The upper deck likely functions as panoramic lounge space. The lower deck would house mechanical systems, sleeping quarters, and core utilities. Structural load paths would run longitudinally along the chassis rails, with cross members supporting the upper glazing. Ceiling height on the main deck could realistically reach 2.1 to 2.3 meters in height. Weight distribution would center low, batteries and water tanks placed between the axles to reduce pitch. Sleeping areas would logically be positioned mid-rear for minimal road noise. Glass to privacy balance would be managed via electrochromic dimming. Thermal insulation would rely on multi-layer composite walls. The kitchen would require compact induction systems to reduce heat output. Water storage capacity in a vehicle this size could exceed 500 liters combined fresh and gray systems. Energy draw would be carefully managed via centralized battery management systems. A modular wet-dry separation would be most efficient. Water recycling technology could reclaim gray water for non-potable reuse. Ventilation would need active moisture extraction to prevent condensation in such a glass-heavy environment. Driver visibility is expansive due to panoramic glazing. In a speculative future execution, augmented reality overlays could project navigation directly onto the windscreen. Semi-autonomous Level 3 capability would be plausible with distributed sensors integrated discreetly. Control hierarchy would likely be minimalistic, haptic surfaces rather than physical